Welcome to Server Logic Simplified.
Imagine a door to your most valuable digital assets. What if someone could trick that door into opening wide just by whispering a few specific words? This is similar to a major vulnerability in web applications that targets your database. An object-relational mapper, or ORM, significantly secures data access in applications primarily by preventing structured query language, or SQL, injection attacks. It acts as a crucial barrier between your application code and the database, ensuring that user input cannot be maliciously interpreted as database commands. The core mechanism behind an ORM's security contribution lies in its use of parameterized queries and its abstraction layer. When you use an ORM to build a query, it constructs the SQL statement in a way that separates the query logic from the data values. Instead of concatenating user input directly into a SQL string, the ORM creates placeholders for data. Then, it passes the actual user input as parameters, which the database engine treats purely as data, never as executable code. This fundamental separation means that even if a malicious user inputs SQL commands, they are never executed. For instance, an ORM might generate a query that looks like select from users where username equals ? And then bind the user-provided username to that question mark. This strict handling makes it virtually impossible for an attacker to inject their own SQL statements. Furthermore, ORMs often provide type safety and validation mechanisms. They expect certain data types for specific fields, which can catch and reject malformed or unexpected input before it even reaches the database. This adds another layer of defense against various input-based attacks beyond just SQL injection. To maximize the security benefits of an ORM, always use its provided methods for all database interactions. Avoid manually constructing SQL queries or resorting to raw SQL execution unless absolutely necessary and with extreme caution. When raw SQL is unavoidable, ensure you implement robust input sanitization and parameterized queries yourself. Additionally, regularly update your ORM library to benefit from the latest security patches and improvements. Beyond direct SQL injection prevention, ORMs offer an indirect security advantage by reducing the surface area for human error. By abstracting away the intricacies of raw SQL, developers are less likely to make common coding mistakes that could inadvertently open security gaps. They enforce a consistent and safer way of interacting with the database, allowing developers to focus on business logic rather than complex and error-prone SQL string manipulation. This also extends to managing database schema changes more safely. Ultimately, by centralizing database interactions through a well-designed and properly used ORM, applications gain a robust defense against one of the most prevalent web vulnerabilities. It empowers developers to build more secure applications with greater confidence, knowing that a significant class of data access threats is systematically mitigated, thus protecting sensitive information and maintaining application integrity.
If this helps you code smarter, like, subscribe, and stay tuned for more.